Now, this is your last question of the exercise 6.5. Fine. In this question, what we have to do, I'm reading this question, then I will explain. Show that the semi-vertical angle of a right circle cone of given surface area and volume maximum. So, area is given to us and volume maximum we have to prove, and we have to prove that the semi-vertical angle is equal to sine inverse 1 by 3. Now, this term will create problems. Semi-vertical angle means what? So here this is the cone, this is the height of a cone, this is the radius of the cone, this is the vertex. So semi-vertical means this whole is a vertical angle. Semi means the half of this. Okay, this angle is given to us. We are assuming that this is theta, suppose. Okay, so we have to prove this theta is equal to sine inverse 1 by 3. And surface area is given to us here. So your surface area is, this is the formula to find the surface area of a cone, pi r L plus r. I'm inserting this and you will get this. So from this equation I will find out the value of L. So this will shift on the left hand side. Here you will get S minus pi r square, and this pi r L equals to, and this pi r will come in the denominator, and this is the value of L. This is your equation number 1. Okay, now volume of the cone is 1 by 3 pi r square h. Fine. So here the value of h you will get from this equation. As you know that this is a relation between slant height and radius. So from this equation you will get the value of h. So it will come out to be this one, L square minus h square. At a place of this h you have to put this value. 1 by 3 pi and r square will remain the same. Okay, just at a place of this h, if I will solve this, so I will get h square, L square minus r square, that is equals to h square. Okay, from this you will get the value of h. To add a place of this h, you have to put this value. Okay, now as you can see that this root is creating a problem. So what I will do, I will square both sides of this equation. So I will get v square, and here you will get pi square by 9, this would be r is to the power 4, r is to the power 4, and here the root will eliminate. So you will get L square minus r square. Okay, now you have to put the value of L from this equation number 1 in this equation. So here I have put, and now you have to simplify it. On simplification you will get this. Okay, so here pi square by 9, r is to the power 4, it will remain the same. Here you have to open this a minus b whole square by this formula, and here you have to simultaneously you have to take the LCM also. So on taking LCM you will get this equation. Okay, this would be a square h square, this square means pi square r is to the power 4, you will get minus 2ab, so 2s pi r square you will get, minus here you will get pi square r square, and when you will take LCM you will get pi square r is to the power 4, and this pi square r square in the denominator you have to write. Now as you can see, the pi square and pi square, r square and r square you can cancel. Okay, so in the next step you have to do that, and at a place of v square I'm assuming that this is your z. Okay, this v square I'm putting, this is equal to z. So let me adjust the next page of this. Here it is. So here v square is equal to z I'm putting, and here it is your pi square by 9, r is to the power 4, so you can cancel out this 2. Pi square will cancel out, and this r is to the power 4 will cancel out with it, with r is to the power 2. Fine, you can cancel these 2, and here you r is to the power 2 will remain. H square minus 2s pi r square you have to write, and I'm inserting this r square into this again, so you will get this step. Okay, now what you have to do, you have to differentiate both sides with respect to r. So this would be dz upon dr equals to 1 by 9, and this would be h square will remain the same, derivative r square will be 2r, so this will be 2h square r minus minus, and derivative r is to the power 4 will be 4r cube. So when you multiply this you will get 8s pi r cube. I know you can find very easily, you can find out the derivative. So this is your equation number 2. Now again you have to differentiate this. After differentiating you will get this step number 3. Okay, now we are putting this equals to 0. Put dz by d equals to 0 in equation number 2, and we get and when you will put this 0, and when you will solve this whole, you will get s equals to 4 pi r square. Fine. S equals to 4 pi r square. Now you have to put this value of s in equation number 3. So your double derivative will be negative. Okay, when you put this, and you have to show it. I'm not showing, but you have to show. Fine. You have to show this step. So your double derivative is coming negative. So it is maximum. Okay. So after this, what you have to do? Let me erase this. This was your figure. This was a semi-vertical angle. This is your radius r, and this is the height h. Okay, fine. Now this is a semi-vertical. If you take this angle, so I'm writing tan theta. Not sorry, sine theta. Sine theta is perpendicular upon hypotenuse. So here, if you take theta as this, so this would be a perpendicular. So it would be r over perpendicular upon hypotenuse. So your hypotenuse will be L. Fine. So sine theta is equals to r by L. R by L. Okay. And here I'm solving from, just wait, here I'm solving from equation number 1. Equation 1 was s minus pi r square over pi r. So here I'm putting this value of s. Okay, that is 4 pi r square. Here you have 3 pi r square over pi r. So this pi will cancel and you will get 3r. So your L is 3r. Okay. Now you have to put this value of L in this equation. So sine theta is equals to r by 3r. So r and r will cancel out. Your sine theta would be 1 by 3. And your theta would be sine inverse 1 by 3. This is how you can prove this. Got it? So this was your question number 26. So at least 2-3 times solve all the questions, then you are able to solve. Fine. So work hard. If you have any doubt in any step, you can ask. Bye bye. Take care. Now we will do miscellaneous exercise of this chapter. Okay. And yes, student, don't leave any example. You have to solve the examples also, to solve each and every example of your NCERT of each chapter. Okay. Now bye bye. Take care. Hello everyone. Now after completing the 5th exercise, that is 6.5, okay, of a chapter application of derivative, now we are solving a miscellaneous exercise. Fine. So here first I'm solving the question number 17 of your miscellaneous exercise. Okay. So here is the question. Here sphere is given to us and a cylinder is inscribed. This cylinder is inscribed in this sphere and radius r of a sphere is given to us. Okay. And we have to prove that the height of the cylinder is equal to 2r by under root 3. So here is a figure. Okay, this OA is a radius of a sphere. OB, we are assuming that that is equals to x, and AB, that is the radius of a cylinder, that is we are assuming small r. Okay, so here all the values I have written. So in triangle OAB, we are applying a Pythagoras theorem. and this r square is equals to x square plus r square will come, and from this data you have to find out the value of r square. So here it is. Okay, now the volume of a cylinder, this is a formula. At a place of r square I am putting this value which I have calculated here, and then your h height of a cylinder is, this is x, OB is x, so your OC is also x, so total height would be 2x. Okay, now just what you have to do, you have to put the values and you have to insert 2x in this. After inserting you will get this equation. Okay, now after getting this equation, just we have to differentiate it both sides with respect to x. So here we are differentiating it, that is equals to pi will remain the same, and when you will differentiate this x would be 1, so you will get 2r square only, minus minus this will be 6x square. Okay, so we are putting, this is our equation number 1. Again we have to differentiate this equation. When you differentiate this you will get minus 12x pi. Got it? So this is your equation number 2. Now we have to put dv by dx equals to 0 in equation number 1. You have to put this equals to 0, so 0 equals to this whole term will come. Okay, now from this data you have to calculate the value of x. Fine, let me adjust the next page of this question. So this 0 equals to 2r square minus 6x square, and this 6x square will come on the left hand side, and from here you are getting the value of x square, that is x square equals to r square by 3, and your x would be r by root 3. It's not x, it's root 3. Just wait, it is root 3. So here the value of x is coming, so x equals to r by root 3. This is your equation number 3. Okay, now we have to put this equation, this value of x in equation number 2. So when you will put this value in equation number 2, you will get minus 12 pi r by root 3, because at a place of x we are putting this value. So after, as you can see here, it is coming negative. If your double derivative is coming negative, that means it is a maximum. So this is what which we have to prove, volume must be maximum. Okay, and height of the cylinder, that is h, that is equals to 2x. So I am putting the value of x here, that is r by root 3. So this is what which you have to prove. So this is how we can solve this question number 17 of your miscellaneous exercise. Okay, there are so many questions in this exercise which are not coming in your board exam. Okay, so that's why I'm just solving a toughest question. Okay, so now after solving question number 17, I'm going to solve question number 18. Okay, I will solve only selected question of this exercise. So if you are getting a problem in other question also, so you can ask. Fine. Now this is your question number 18 of your miscellaneous exercise. This is one of the most important question of your exercise. Okay, so in this question what you have to do, here cone is given to us and a cylinder is inscribed into it. Okay, as I have shown in the figure. And the height of the cone is given to us, which is small h. This h is given to us, and we have to prove that the height of the cylinder. So I am assuming this height y. Okay, and this hole is h and this is y, and so AB would be h minus y. This angle is also given to us, semi-vertical angle, that is alpha. And this small r, I'm assuming that this is a radius of cylinder. Okay, and this x is the radius of cone. Okay, so all these things you have to write in your exam. I have not written here, but you have to write. Okay, so we have to prove that y is equal to h by 3. That is, height of the cylinder is 1/3 of the height of the cone. Okay, and we have to prove that the volume is maximum. This volume of the cylinder is maximum. Okay, now as we can see that triangle ABC and triangle ADE both are similar triangle. Okay, if they are similar, so as we know that the ratio of their corresponding side, that is AD over AB, is equals to DE over BC, would be equal. You have done this theorem in your 9th standard, I think so. Okay, now you have to put the value here. AD is AD, that is the height of the cylinder, that is h. You have to put your AB is h minus y. You have to put DE, that is the radius of the cone, that is x, and BC is the radius of the cylinder, that is r. Okay, so now you have to cross multiply. This will be HR and this would be HX minus YX. So from this data I'm going to find out the value of y. So this is how you can find out the value of y. Okay, now in triangle ABC I am using trigonometry, that is tan alpha is equals to perpendicular over base, so that is BC over AB. So value of BC is small r and AB is h minus y. So you have to cross multiply and your value of r would be h minus y into tan alpha. This is the radius of a cylinder. Okay, and this is the height of the cylinder. Now you have to apply the formula. Volume is equal to pi r square h, that is pi r square. Your height is y, so that's why I am writing y here, not h. Pi r here, this value of r is this, so you have to put at a place of r. So here r square, so you have to square the all values. Okay, into y. I'm just going to simplify this x minus y. I'm opening this bracket, so a square plus b square minus 2ab, and this tan square and pi I'm writing first, and into y. Then you have to insert y into this bracket. You have to copy pi tan square alpha, bracket open. Now you have to insert y into h square. This would be y cube minus 2hy square. You will get this equation. Okay, I know you can solve this up to this step very easily. Okay, now what I'm doing, I'm differentiating both sides with respect to y. Okay, I'm differentiating both sides with respect to y. See what will happen. Let me adjust the next page of this question. It's a very lengthy question. Now when you will differentiate, you will get this step. This is your equation number 1. You have to write. Now you have to again differentiate this with respect to y. So this pi tan square alpha will remain the same. Your h is a constant, so that will be 0. This will be 6y minus 4h. You have to write. That is the equation number 2. Okay, now we have to put dv by dy equals to 0 in equation number 1. So when we put 0 is equals to tan square alpha is coming, bracket open, and you have to copy all this like this. Now in the next step, this pi tan square alpha will come on this side, that would be 0, and you have to write this one. Side by side I am just splitting the middle term of this. Okay, 3hy minus hy I am writing at a place of this like this. Okay, middle splitting you are solving from your 9th standard. Just you have to take common. After taking common, you will get these two factors. Okay, now you have to put this factor equals to 0 or this factor equals to 0. So your h minus y equals to 0. From this factor you are getting h equals to y, which is not possible. Okay, from this data you are getting y equals to h by 3. So this is possible, so you have to take this value. As you can see, you have to prove this one. Okay, now you have to put this value in equation number 2, and when you put this value in equation number 2, you will get a negative value. So it is maximum. So I'm not showing here, but you have to show. Okay, and this is, you have to prove the height of the cylinder is equal to 1/3 of the height of the cone. Now your R was this one. Okay, so you have to put the value of y here. When you will put the value of y at a place of, sorry, at a place of y, you have to put h by 3. So your h minus, at a place of y I am putting h by 3. So you have to take LCM here, and you will get 2h by 3 tan alpha. This is the value of R. Similarly, now v is equal to pi r square h. This is the formula. Pi will remain the same. At a place of this R, I am putting this value 2h by 3 tan alpha, and this is whole square because R is in square, into h. H is your h by 3 into, not h, it would be y, sorry. So your y is pi by 3, you have to write here. Okay, now just you have to simplify. After simplification, you will get, which you have to prove. Okay, so this is one of the very important question. So please solve it at least 3 or 4 times. Fine. The weightage of that question will be of 6 marks in your exam. So please concentrate it and solve. Okay. Okay, children. Bye bye. Take care.